In this video, we're going to look at the vertex form of a quadratic function. I've talked about standard form in one of my other videos. This time we're going to look at the vertex form. And if you have seen the video over the vertex form of the absolute value function, there are a lot of similarities. We have a in front multiplied by x minus h squared, and then adding k on the outside. Now, one of the similarities is the vertex. You find the vertex by taking h and k. Change the sign of your h, so instead, like if it was x minus 2, it wouldn't be a negative 2 here, it'd be a positive 2. The one on the outside, keep it the same. And your axis of symmetry, we can get from the vertex. It's x equals h. Now, this is useful when you're looking to graph it pretty quick. You don't have to use the negative b over 2a to get the vertex. We can just look at it and see it. It's also useful for seeing the transformations of the functions compared to the parent function. So, for instance, if I had f of x equals negative x plus 5 squared, I can look at this and tell pretty easily that compared to the parent function, which the parent function is, remember, x squared, I can tell pretty easily that compared to this one, this graph has been reflected over the x-axis, and it's also, by looking at this, I can tell it's been moved left 5 units. Remember, changes on the inside are opposite direction of what you would think, and it's horizontal. Or let's take equals 1/3 or 1/2 x squared plus 3. This tells me right here that it was a vertical shrink by a factor of 1/2, which means it's twice as flat. And this tells me it moved up 3. And it's vertical because it's on the outside of the x squared. Or let's take negative 2x plus 4 squared. That's good enough. There are 3 things that were done to this one. There's a reflection across the x-axis. There's a vertical stretch by a factor of 2, which means it's twice as skinny, twice as tall. And then the plus 4 here means it moves left 4. So vertex form is it's very easy to see what the transformation from the parent function was. Now, we can also use it when graphing. So let's look at a couple of graphs for quadratics. So if I had f of x equals x minus 2 squared plus 3, I can tell just by looking at it that the vertex is at positive 2, positive 3, and that the axis of symmetry is the line x equals positive 2. Now, I can graph this pretty easily. 2, 3 is my vertex. So if I, you can plug in. I'm taking the shortcut to save us a bit of time. So x minus 2 squared plus 3, and look at the table. Taking a shortcut here. Now, 2 is my center point. So others I can plot on here are 0, 7, 1, 4, and then over here I can plot some more points as well. I didn't connect my dots very well, but oh well. So I can use that to graph it pretty quickly. Okay. If I had g of x equals x squared minus 4, I can tell by looking that my vertex is 0 because there's nothing with the x squared on the inside, minus 4 for the y value, and that the axis of symmetry is x equals 0. So when I go to plot my points, again, you can take a shortcut, but 0, -4 is my vertex. So 1, -3, 2, 0, 3, 5, and that's probably enough to be going on with. I can graph it pretty quickly. But again, if you don't want to plug in and do it that way, you can also just plug it into the calculator. This also works for inequalities. So let's take f of x less than negative x minus 3 squared. Whatever. Okay. So I can tell my vertex is positive 3, 0. And my axis of symmetry is x equals positive 3. So 3, 0 is my vertex. And I can plug in other numbers. Excuse me. Again, you can take the shortcut if you want, but really when I say shortcut, what the calculator does for us is it basically does the plugging in for us. So if I want to figure out what the y value is at positive 2, it'll do it for me. If I want to know what it is at positive 1, it does it for me. So 0, -9, 1, -4, 2, -1, and then they repeat over here. With this one, I'm going to use a dotted line because it's just less than. So dotted lines. Okay. There's my graph. And then for the shading, remember that you are going to shade below when it's less than. So below means I shade down here. Let's take another one. Greater than or equal to 4 times x plus 1 squared minus 7. So the vertex on this one, remember, change the sign of the one on the inside, so that's -1. Keep the one on the outside, -7. So -1, -7 is my vertex. My axis of symmetry is the line x equals -1. So I can plot some points pretty quickly. Let's see, -3, yeah, so -3, 9, -2, -3, and then I've got that, and then they repeat on the other side. So it's a pretty tall, skinny one, and I'm going to use a solid line to connect the dots on this one. So solid line. Remember, it is supposed to be curved, not straight lines. Hopefully you can draw better curves than I did. And this one, it's greater than, so I shade above the vertex, which is here. Alright, so I think I'm going to stop here for this video, and I will see you next time.